All right, this is section 3.1, and it's finding probabilities and odds. You've done some of this in past years, but probably not into this much depth. So I would like you to pause the video and look over your vocab words. So we're going to talk about outcomes, events, and sample spaces. So sample space is all possible outcomes. You're going to hear that quite a bit. So starting with the first problem, you flip a coin twice. How many possible outcomes are there in the sample space? List all the possible outcomes. So this kind of can get a little bit tedious. So I'm going to represent this by H for heads, T for tails, and you're flipping it 6 times. So our first possible outcome could be like HH1, and then we would have HH2, HH3, HH4, and that's standing for heads, heads 4, heads, heads 5, and heads, heads 6. So I'm going to do this with all of the outcomes. So I would encourage you to pause your video and go through and do that. Okay, so I went ahead and I listed out all of the possibilities for rolling or for flipping 2 coins and flipping them 6 times in a row. Okay, so the next question is you flip a coin and roll a number cube. A number cube is a way of saying a dice. How many possible outcomes are there in a sample space? So flip a coin and roll a dice. You would have the possibility of either heads or tails. So, if you flip your coin, you're either going to get heads or you're going to get tails. And then each of those would have an outcome of 6 because each side, there's only 6 sides to a dice. So each one of these is going to have an outcome of 6 possibilities. So that's telling us basically I could either get heads 2, heads 3, heads 4. I'm going to do the same thing with tails. So I could possibly get up to 6 different combinations with tails. So that's an example of how to make a sample space. Okay, so this little number line chart is showing you the probability of an event. So this is common sense. I feel like obviously if something is a probability of 0, it's not going to happen. 25% like unlikely, 50% is equal, 75%, and 100% is certain. So, for example, like when the weather says that there's a 75% chance of rain today, you can pretty much bet that you're going to see rain at some point in the day. So you see these type of predictions and numbers all the time in everyday life, and I feel like it's pretty much common sense. Favorable outcomes are outcomes for a specified event. So theoretical probability is the number of favorable outcomes over the total number of outcomes. And we represent probability by putting a P for probability. So this problem, you and your friends designed a t-shirt. The table shows the number of t-shirts you have in each design. A student chooses a shirt at random. What's the probability that a student chooses a red shirt? So we're going to do the probability of a red shirt. And what we're going to do is the number of red over the total amount to decide the probability. So we have 30 shirts total on your chart, and the number of red shirts would be 12 because we have 8 and excuse me, not 8. We have 6 and 6 together making 12. So what I'm going to do is simplify this, and it simplifies down to 2/5. So 2/5 would be 0.4. So it's could happen, but it's less likely to happen than a different color. Okay, for the next question, what is the probability that a student chooses a t-shirt with a gold emblem? So we're finding the probability of gold, and we have a total number of shirts again of 30. And then if you add up the gold emblems, there are 16 total. So if you simplify that, you would have 8 over 15. Okay, the next problem, you toss a coin and roll a number cube. What's the probability that the coin shows tails and the number cube shows 4? Okay, so think about it.